Imagine a time before time, a moment so primordial that it defies our understanding. Before light, before matter, before even space itself, there was nothing but an endless void. This was the singularity, an infinitesimal point containing the potential for everything that ever was, is, and ever will be. It was a point of infinite density and temperature, a cosmic seed waiting to burst forth. Then, 13.8 billion years ago, came the Big Bang, a moment of unimaginable energy and creation. The universe exploded into existence, a fiery maelstrom of energy expanding rapidly in all directions. There was no sound, no light, just an unimaginable expansion from an infinitely small point to something vast and incomprehensible. Space itself was stretching, creating the dimensions we now inhabit. The very fabric of space-time was born in that first instant, weaving the intricate tapestry of the cosmos. In the blink of an eye, the universe cooled, transitioning from a searing hot plasma to a more stable state. From the primordial soup of energy, the first fundamental particles began to condense, forming the building blocks of all matter. Quarks, the building blocks of protons and neutrons, materialized from the cooling energy, setting the stage for the formation of atoms. With them came electrons, the negatively charged particles that would one day orbit the nuclei of atoms, giving rise to the complex structures that make up our universe. The universe, still young and incredibly hot, was a chaotic sea of these newly formed particles. Collisions were constant, energy transforming into matter and back again in a cosmic dance of creation. As the universe expanded and cooled further, a new chapter began. Protons and neutrons, drawn together by the strong nuclear force, combined to form the first atomic nuclei. The universe was now filled with a sea of hydrogen nuclei, the simplest and most abundant element. But the universe was still too hot for atoms as we know them to exist. Electrons, buzzing around at incredible speeds, were constantly knocked away before they could settle into orbit around the nuclei. The universe remained a glowing fog, opaque to light. The expansion that began with the Big Bang continued relentlessly. Space itself stretched, carrying galaxies along with it like ships on a cosmic tide. This expansion wasn't just a movement through space, it was the expansion of space itself. This period of rapid expansion, known as inflation, is a crucial part of the universe's story. It explains why the universe appears so uniform on large scales and why the cosmic microwave background radiation, the faint afterglow of the Big Bang, is so evenly distributed. As inflation ended, the universe continued to expand, but at a more leisurely pace. This expansion continues to this day, driving galaxies further apart from each other. It is a testament to the incredible power of that initial event, the Big Bang, that continues to shape the cosmos. The universe, though still young, had begun to cool significantly. Electrons, no longer moving at such frantic speeds, could finally be captured by the hydrogen and helium nuclei. This marked a pivotal moment. The universe became transparent to light. Gravity, the architect of the cosmos, began to exert its influence on the vast clouds of hydrogen and helium gas that now filled the universe. These clouds, drawn together by their own mutual gravitational attraction, began to collapse. As these clouds contracted, they spun faster and faster like a figure skater pulling in their arms. The temperature at their cores increased dramatically, creating regions of immense pressure and heat. These were the crucibles in which the first stars would be forged. Section 5. Stellar Alchemy. Deep within the collapsing gas clouds, the pressure and temperature reached unimaginable levels. Hydrogen nuclei, forced together by the immense pressure, began to fuse. This process, nuclear fusion, released enormous amounts of energy, lighting up the universe with the brilliance of the first stars. These early stars were giants, much larger and hotter than our own sun. They blazed brightly for millions of years, their intense radiation illuminating the surrounding gas clouds, but their lives were short, ending in spectacular supernova explosions. These supernovae were not just destructive events, they were also creative forces. The intense heat and pressure of these explosions forged heavier elements like carbon, oxygen, and iron. These elements, scattered into space by the supernovae, would become the building blocks of planets and eventually life itself. Section 6. Galactic Dances. Over billions of years, gravity continued to sculpt the universe. The first stars, clustered together in loose associations, gradually coalesced into larger and more organized structures, galaxies. These galaxies, vast islands of stars, gas and dust, came in a variety of shapes and sizes. Some were spiral galaxies like our own Milky Way, with graceful arms of stars and gas. Others were elliptical galaxies, smooth and rounded, or irregular galaxies, their shapes seemingly random. Galaxies themselves were not static entities, they interacted with each other, colliding and merging in spectacular displays of cosmic fireworks. These collisions, though seemingly destructive, could actually trigger new waves of star formation, enriching galaxies with heavier elements and shaping their destinies. Section 7. A Spark of Life. In a quiet corner of the Milky Way galaxy, a yellow star ignited, our Sun. Around it swirled a disk of gas and dust, remnants of the cloud from which the Sun had formed. Over millions of years this material clumped together, forming planets, moons, and asteroids. One of these planets, the third rock from the Sun, was Earth. Conditions on early Earth were harsh, with volcanic eruptions, a toxic atmosphere, and constant bombardment from asteroids. Yet, in this seemingly inhospitable environment, life emerged. No one knows exactly how life began. Perhaps lightning sparked organic molecules in a primordial soup. Perhaps life arose in the depths of the oceans, near hydrothermal vents spewing chemicals from Earth's interior. However it happened, life, once just a possibility, became a reality on our planet. Section 8. The Ascent of Humanity. Life on Earth was incredibly resilient, showcasing an extraordinary ability to adapt and thrive in a multitude of environments. Over billions of years it evolved and diversified, adapting to changing environments and filling every niche imaginable. From the depths of the oceans to the highest mountains, life found a way to flourish. From single-celled organisms to complex plants and animals, life's tapestry grew richer and more intricate. Each new species added a unique thread to the ever-expanding web of life. One lineage of animals, the primates, developed large brains and remarkable dexterity. These traits allowed them to manipulate their environment in ways no other creatures could. Among the primates, a new species emerged in Africa a few million years ago, Homo sapiens. These early humans were distinguished by their upright posture and advanced cognitive abilities. These humans, with their large brains and capacity for language, were unlike any creature that had come before. They could communicate complex ideas and work together in ways that transformed their world. Humans possessed a unique ability, the capacity for abstract thought, self-awareness, and curiosity about the world around them. This curiosity drove them to explore, create, and innovate. They developed tools, learned to control fire, and created art and music. These advancements were not just practical but also enriched their cultural and social lives. They looked up at the stars not just with awe but with a desire to understand their place in the vastness of the cosmos. This quest for knowledge and meaning set them apart from all other life forms on Earth. Section 9. Our Cosmic Legacy. We are the inheritors of 13.8 billion years of cosmic evolution, a journey that began with the Big Bang, and has led to the formation of galaxies, stars, and planets. We are the product of countless generations of stars that lived and died, their explosive deaths seeding the universe with the elements necessary for life. These elements, forged in the hearts of stars, spread across the cosmos, eventually coalescing to form new stars, planets, and ultimately, life itself. We are the universe becoming conscious of itself, capable of not only comprehending its own origins, but also marveling at its own complexity and beauty. Our curiosity drives us to explore, to understand, and to push the boundaries of what we know. Scientists and astronomers work tirelessly to unravel the mysteries of the cosmos. The very atoms that we are made of were forged in the hearts of stars, through the process of nuclear fusion, making us in a very real sense, children of the cosmos. This connection to the cosmos is profound, reminding us that we are part of something much larger than ourselves. Our journey is far from over. We have only just begun to explore the vastness of space, to send spacecraft to distant worlds, and to dream of what lies beyond our current reach. We have only just begun to explore the vastness of space, to unravel the mysteries of the universe, and to understand our place within it. Each discovery brings us closer to understanding the fundamental nature of reality, and each question answered leads to new questions and new frontiers to explore. As we study the stars and galaxies, we gain insights into the history of the universe and our own origins. The future holds endless possibilities for discovery, for understanding, and for ensuring that life, Our most precious inheritance continues to flourish on this planet and beyond. Together, we can build a future where humanity thrives, exploring the cosmos and expanding our horizons, ensuring that our cosmic legacy endures for generations to come.